Hi guys, it's Miss Katz again, and today I'm going to be solving all the problems in the MSG for Unit 2, page 4. So this is our review sheet for the test for this unit. So this kind of covers almost all the topics that we worked on in Unit 2. And we're going to start out with talking about ratios. Let me zoom in here a little bit so that you can see a little bit better. And the first question asks, what is a ratio? Well, as you look in the vocabulary section or in the glossary section of your MSG, you find that a ratio is a comparison of two numbers. A rate is a special kind of ratio that compares quantities measured in different units. So a rate is a ratio that compares two quantities, measured in different units. And a unit rate is a special kind. So we went from a ratio to a special kind of ratio, which is a rate. And then a unit rate is a special kind of rate. It's a comparison of two numbers or two measurements in which one of the terms has a value of 1. What that means is that, like, for example, miles per hour, so how many miles in 1 hour, or beats per minute, how many times your heart beats in a minute, in 1 minute. Everything when it deals with a unit rate deals with 1. The word 1 should be clear on your mind when you're dealing with a unit rate. And what is a percent? A percent is simply a number out of 100. Part of 100, which is part of a whole. All right, we move on to ratio tables, which has been one of everybody's favorite topics this unit. And simply in ratio tables, we're looking for the relationship between the top number and the bottom number, and we're looking to replicate that relationship throughout the ratio table. Now, we use lots of different methods, but in this particular case, I'm going to do it using multiples. So we want to figure out, how would I get from 9 to 18? Well, we know that 9 times 2 is equal to 18. So whatever I do to the top of a fraction, I always have to do to the bottom. So if we multiply it by 2 on top, I need to multiply by 2 on the bottom. And that means that this box will definitely be 24. Now, I'm going to go to this number. The relationship I have here is the 12 to 36 relationship. And to get from 12 to 36, I multiplied by 3. Whatever I do on the bottom, I'm going to do on the top. And 9 times 3 is 27. All right, and again, we're going to go down to this relationship on the bottom because we have the 48 that was given. So 12 times 4 gives us the 48 we have here. Whatever I did on the bottom, I have to do on the top to keep these fractions equal, these relationships, these ratios equal. And 9 times 4 is 36. In the last case here, I was given 45, which is on top, so I have to look at how I got from 9 to 45, and we multiplied by 5. And we replicate that same relationship on the bottom, and we get 60. Now, in this case, it was sort of skip counting, right? It went from 9 times 2, 9 times 3, 9 times 4, 9 times 5. Please don't assume that that's going to always be the case when you're doing a ratio table. You need to look at your two relationships and apply those relationships accordingly. All right, question number 6 is asking us to find, or is telling us that 80 is 25% of what number? Now, we did this type of problem a bunch of different ways, but I'm going to use proportions here because it's really the focus of this unit. I want you to notice 80 is 25%, which means 80 is our part. And remember that the proportion relationship in a percent proportion looks like this. The part of our whole is equal to the percent out of 100. Because remember, percentage is a part of 100. So if 80 represents 25%, 80 is our part, and we need to figure out what the whole is. And they gave us the 25%, and it's always out of 100 because percents are always out of 100. Now, there's a bunch of different ways to do this. I'm going to simplify this fraction. So I have a number that might be compatible with 80. I know that 25 goes into 25 once, and it goes into 100 4 times. Now that I've done that, we're going to apply those same rules that we applied for that ratio table to these fractions. If they need to be equal, whatever we do to the top to get from one to the next, we also have to do to the bottom. So on the top here, we multiplied from 1 to 80, we multiplied by 80. Whatever I did on the top, I have to replicate on the bottom. And 4 times 80 happens to be 320, and that will be the answer. If I want to find 30% of 70, all right, let's talk about that. I need to find 30%, which means I need to find the part. So I don't know the part, but I had 70 total, and the percentage they gave me was 30 out of 100. Again, I don't have a compatible relationship here, but I could make one. 30 and 100 share a factor of 10. So if I simplify those, 30 becomes 3 if I divide by 10. And 100 becomes 10 when I divide by 10. Now the relationship between them should be pretty clear. 10 times 7 got me 70, and 3 times 7 will be 21. In this particular proportion, we are looking to figure out what is missing, what that value of x would be to make this sentence make sense. So what we do, again, I'm going to simplify. I don't have a clear relationship here that's easy for me to use. But if I divide by 5 on the top, I get a 3. And by 5 on the bottom, I get a 5. Now, I can get from 5 to 30 by multiplying by 6. Whatever I do on the bottom, I do on the top. So the answer here is 18. Now, in number 9, we're looking for a unit rate. They told us it was $27 for 9 tickets. But in a unit rate setting, I want to know how much it is for 1 ticket. So if it's $27 for 9 tickets, if I divide 27 by 9, I find that it's $3 per ticket, per 1 ticket. A unit rate is always per 1. All right, let's take a look at the problem at the bottom here. Jaden drove 260 miles in 4 hours, and Jada drove 210 miles in 3 hours. I want to know who drove the fastest rate of speed and how I knew that. Well, in order to be able to compare these guys, right now, they're both going in miles and both going in hours, but they've traveled different distances in different times. We need something to be the same. So we're going to figure out how many miles each of them drove in 1 hour, finding their unit rates. Then we can compare those unit rates to see who actually drove fastest. So 260 miles in 4 hours. If I take 260 and I divide by 4, 4 goes into 26 6 times, and I have 20 left. 4 goes into 25 times. So I know that Jaden went 65 miles per hour. Okay? So every hour that Jaden drove, he drove an average of 65 miles. Let's take a look and see how far Jada drove. So Jada did 210 miles, and she did it in 3 hours. When I divide, I get 70. So Jada drove 70 miles per hour. So every hour that Jada drives, she went 70 miles. So who drove fastest? Obviously, based on that information, Jada drove fastest. She went more miles in the same amount of time. How do I know? Because I found the unit rates and compared them. And we found out that Jada went more miles in the same time. She's got the lead foot. All right, we're going to switch over to the other side of the page here. Question number 11. I'm just going to fold this over so I have a little bit more room to work. Question number 11 says that a circus elephant is going to stand on a ball. Lulu the elephant weighs 2 tons. If the ball can hold up to 3,000 pounds, will Lulu make it? Explain your answer. Will she be able to stand on that ball without falling? So here's the deal. This is one of those things that you have to look up or know, and this information is in your MSG. So if you didn't know how many pounds were in a ton, you could have found that pretty easily. But if she weighs 2 tons, okay, she weighs 2 tons. Each ton, 1 ton, equals 2,000 pounds. So if we know that, and Lulu weighs 2 tons, she will actually weigh, Lulu weighs 4,000 pounds. She is a big old elephant. If the ball can only hold up to 3,000 pounds, will she make it? The answer is no. She is heavier than 3,000 pounds. All right, now the table below shows the number of each item sold at a concession stand, and we want to look for a 3-to-4 ratio. Based on the numbers that we have there is no 3-to-4 ratio that stands out. We don't have the numbers 3 and 4. But what we do notice is that all 4 of those numbers share a common factor of 5. So I'm going to recommend that you simplify by 5. Now this method works only when all the numbers in your set have the same common factor. So when you divide by 5 here, you get a 4. When you divide by 5 here, you get a 3. When you divide by 5 here, you get a 5. And when you divide by 5 here, you get a 6. Now we're looking for the 3-to-4 ratio. Nachos now are 3. And 4 is popcorn. So nachos to popcorn represent a 3-to-4 ratio. And if you were to take 15/20ths, you would find if you divide by 5, you get 3 and you get 4. So you can simplify that fraction down to 3/4 ratio. All right, the ratio of boys to girls in a class is 4-to-8. If there are 24 students in the class, how many are boys? All right, so let's talk about what we know. We know that we have, in the classroom, for every 4 boys, there are 8 girls. And that would be a total of 12 students in that group. So for every 12 students I have, 4 of them will be boys, 8 of them will be girls. Now, in this case, I don't have 12 students. I actually have 24 students. So let's take a look at what that looks like. We're comparing boys, because that's what we're looking for, to total. So the boys to total relationship I start with is 4-to-12, because 4 out of every 12 total students are going to be boys. In the case here, they told us that we had 24 total students, and we wanted to know how many boys we have. If we take a look at that problem, how did I get from 12 to 24? I multiplied by 2. Whatever I do to the bottom of a fraction, I have to do to the top. So the top number ends up becoming 8. There will be 8 boys in a class of 24. All right, the next question is a percentage problem. It says that in a class of 40 students, that's our total number of students, 30% of them did return their permission slips for the school field trip. We want to know how many students did not return their permission slips. We can do this a bunch of different ways, but I would recommend this way. If 30% of our students did turn in their permission slip, what percentage of students did not return their permission slip? Well, if there's 100% of students in a total, 30% did return them in. That leaves 70%. 70% did not turn in. So if we can find what 70% of 40 is, then we can solve this problem. There's 2 different ways I'm going to solve this problem. I'm going to use our proportion, and I'm also going to use multiplying just so we can reinforce that concept. So if 70% did not turn in, so we know that out of the 40, we want to know how many students would represent 70%, and percentage is always out of 100. Again, we can simplify by a factor of 10. So we're going to get 7 and 10. How did I get from 10 to 40? Times 4. So 7 times 4 is 28. So there would be 28 students did not turn in the form. Now, I want you guys to notice, if 70%, is it tipping towards 40 or is it tipping towards 0? 70% is over 50%, which means we're over half here. So the number that we get should represent more than half of what we started with. And half of what we started with would be 20. And 28 is definitely more than that. So our numbers make sense based upon the information that we have. Now, if you didn't use a proportion, you could also change this percentage into a decimal. So remember, to change a percent into a decimal, we move the decimal 2 places to the left. So this is 70%. as a decimal. It said 70% of the students didn't turn in their permission slip. Of in math means multiply. So if we take 40 and we multiply it by 70% as a decimal, and we move the decimal the right number of places, if you notice, we're still going to get 28. Either method will be fine. You can use either one. All right, question number 13 says that the table below shows the cost for varying numbers of books. If the rate stays the same, we have to determine the value of n. So if I have 6 books, it's $24. If I have 10 books, it's $40. 12 books, it's $48. And we want to know what 20 books would cost. Now, this is really a ratio table just turned on its side. And I see a really clear relationship here. How did I get from 10 to 20? I multiplied by 2. Well, if I'm buying twice as many books, it will cost me twice as much money. So n should equal $80. I hope this helps you guys understand better how to solve the problems on page 4B. I'll post another video on how to answer the problems on page 5 so that you guys can be completely ready for your test for Unit 2.